Alrighty. So, definite integrals. That looks like a P. Will be something like integrating 2x dx from 1 to 5. Right? Rebecca, how would we integrate that? What does it become? Say what? So what's the antiderivative? Okay, from 1 to 5. And then we plug in the limits, right? Top minus bottom. 5 squared minus 1 squared. So 25 minus 1 is 24. Hey Alex, we have on your desk the notes, and the green thing is your new homework section for chapter 7. Okay, but indefinite has no limits. We're just integrating 2x dx. So we do it the same way. The antiderivative is x squared, but we don't have the limits from 1 to 5. Now, when we're integrating an indefinite, there's always a plus c. Remember we've talked about that plus c before? Plus some constant. Because x squared plus 5's derivative is 2x, right? X squared plus 7's derivative is 2x. X squared plus a million's derivative is 2x. There's some constant that could be hiding there. And if you don't put that plus c on an indefinite integral, it's a big problem. They will knock your points if you're missing the plus c. So on all indefinite integrals, you have to put a plus c. Okay, so ways we've learned how to determine antiderivatives when we're given a function. We've learned straightforward, just this, using the antiderivatives. Sometimes you need to do a little manipulation to simplify them, like 1 over square root of x. You would change it to x to the negative 1/2. So sometimes you need to simplify first. Some may need to be simplified first, or manipulated just a little bit, and then you can take the antiderivative pretty straightforward. In 7.2, our next lesson, we're going to learn how to integrate more complicated integrals by using substitution method. And after the AP test, we're going to learn a third way that's called by parts. We'll still have a whole month. I did get, I'm thinking after the AP test too, we'll have one day where we have a panel of professionals who use calculus in their everyday life. I was talking to a friend of mine who's a pilot. He was like, I never knew how useful calculus was until I went to flight school. And something about like when they bring the wheels out, it's like the area underneath the curve determines how much space they need to bring the wheels out. I don't know. Anyway, I was like, whoa, come talk to my class. And he agreed. So in May, I'm going to get him and hopefully a couple others to come talk to you who use calculus in like everyday life to come talk to you about it. I think that would be cool. But after the test, of course, because we only have so much time to study for the test. Okay, so when we solve differential equations, oh gosh, sorry, it's in my eye. We have, sometimes we're just solving dy dx, right? and sometimes we're solving for y. If we take the derivative of y, we can write it in two ways, right? dy dx, or we can write it as y prime. What's the derivative of dy dx? d2y over dx squared, so that's the second derivative, or y double prime. Okay, growth and decay are exponential equations, and I think it's in 2 days. I think it comes in a couple days. Slope fields. Okay, so a quick review. How would we integrate x to the n dx? Integrate it. Take the antiderivative of x to the n dx.
1 over n minus n plus.
So it's x.
1 over n plus 1. Then in parentheses.
Anything else?
Plus.
This is an indefinite integral, so we have to have that plus c. That's the power rule. You increase the power, n plus 1, and then divide by that power. Okay? So let's try some down below. Again, this is just a straightforward method. Some may need to be adjusted a little bit before you take the antiderivative, but try numbers 1, 2, and 3. Integrate all three of those. And they're right here. We need to use the box for an activity, so they're out of the box.
Number 2, help us out.
I'm seeing some interesting things on number 2. Okay, well, number 1, first of all, remember with integrating, you can pop out that 2 if you like that better. You can pop out constants that are multiple constants. And the x gets raised to the 5th power, but then you have to divide by 5. So make sure you have that 2 there. It is still there. It's not 1 over 5.
Question. This equation, that's to, if I want it, that's to integrate. I don't get it. So like when you take the integral of something, it's area under a curve. So this is the formula we'd use to find the area underneath that curve.
Plus some constant. So even the 2x plus 4, what that's like, with some loop-de-loops. So area underneath the curve. But it goes on forever, so we have some constant.
And I'm just going, so this, when we do it with the indefinite, we're just finding an equation to solve for the area under the curve.
And you'll see, actually, let's see if we have it. There's a way to find C. I don't think we're going to do it on one of these today. But Yisu and I, remember Wednesdays, we have, actually number 3 will be solving for C. On Wednesdays we have AP test question practice. John came for a minute, Yisu came So on Wednesday next week, you can come for a test practice. And we did one of these where you can find and we'll do on number 3, we'll find C. You can find C and find the exact equation.
Yeah. Cool.
Yeah. Yeah. Until like 3:30. Okay, so number 2, So who manipulated it to be x to the negative 1 dx? Yeah. Okay, well, if we use the power rule on that one, we'd increase it to x to the 0, which means then we divide by 0 plus c. What's wrong with that? You can't divide by 0. You can't divide by 0. What is the integral, or think backwards. What is the derivative that equals 1 over x? Natural log. I saw Misha got it. I don't know, I didn't see if anyone else got it. But 1 over x is natural log x plus c. And this one is also natural log, because the 2/3, if the 2/3 pops out, then it's just 1 over x again. So it's 2/3 natural log x plus c. Because think of what the natural log function looks like. It's only positive x's. Okay. Probably not. Okay, flip over to number 4. I think you can probably do number 4. And maybe number 5. Try both of those out. Since they're indefinite intervals, don't forget the plus c. So far, number 1 looks great. Everyone has number 1. Okay, John, you want to go show number 1 up on the board? Oh, careful. Okay, what do you think? Thumbs up, thumbs down? Did you get the same? Yeah. How come the 1/2 at the beginning is now positive? Not negative. Yeah, you divide by a -2, so that would a negative divided by a negative would be positive. Good. Okay, who thinks that they're confident on number 5? Okay, who wants to go up and do number 5? Okay. Cubed root of x. That's a little tricky. Were there any questions on number 4? When I was walking around, I think everyone pretty much had that. Maybe. Yeah, you have to go back and change it. It's really annoying. I feel like I spend half my lessons changing it to skinny markers. Okay, what do you see? Thumbs up, thumbs down? Huh?
Oh, plus C.
Plus C, important. Now, you didn't write the step of how you got this. So how did you, because I'm pretty sure you have to have some manipulation, right, to get that? Good. So cube root of x is x to the 1/3. But since it's in the denominator and you move it up, it becomes x to the negative 1/3. And so we increase negative 1/3 plus 1. Negative 1/3 plus 1, or plus 3 over 3, is 2/3. That's why that becomes 2/3. But then we always divide by that power. So another way to write this, when you divide by a fraction, you flip and multiply, right? So you can flip it to 3 over 2 times the 2, which is 6/2, x to the 2/3 plus c. No. Oh, which is just 3? Yeah. I was like, why do I have a 3 on my paper? Because that simplifies further. And this one, you could also write this one as 1 over 2x squared plus x squared over 2 minus x plus c. Okay. Any questions on those? Don't forget that plus c. On which one? A negative on the exponent? Well, we're increasing by 1. When we moved this up, it became a negative 1/3, but we're increasing by 1, so we're adding 3 over 3, which makes a positive 2/3. Okay. Any other questions? Okay, well now we're going to learn how to find the antiderivative of a chain rule. Yep. It's not too bad. It's just like you're undoing the chain. So first, you're going to do a chain. So take the derivative of sine 5x. Sine of 5x. Which requires chain rule, right? Because we have a function inside of another function. Okay, Ethan, you done with that one? Will you come write what you got for the derivative of sine of 5x? Okay, what do you think? Agree? Disagree? Yeah, good. Good, because what you do is the derivative, remember the formula, d dx of f of g of x equals what? F prime of g of x times the derivative of the inside. Okay, so when we integrate, we're going to do the reverse of that. Okay, when we integrate, we're going to integrate cosine first. Okay, what's the antiderivative of cosine? It's sine, because when you take the derivative of sine, it doesn't change sign. That's a lot of signs in there. It stays positive. Okay, so cosine's a little tricky going back and forth. When you take the derivative of cosine, you change to a negative sign. When you integrate cosine, it stays positive sign. So positive sign of, we're going to undo the chain. Still the inner function, but instead of timesing by the derivative, you have to undo that. You would what? Divide. And that's kind of similar to what we do here, isn't it? We end up dividing by the power. So to undo the chain, there'll be a sign of that part still, but divided by the derivative. The derivative of 3x is 3, right? So we have 3 sine 3x divided by 3, but those 3's cancel out, plus c, so we get sine of 3x plus c. And you can double check, you can always now take the derivative of that and make sure it works. Sine of 3x, the derivative of sine would be cosine, right? Cosine 3x times the derivative on the inside, which is 3. Cosine 3x times 3. Okay? So, let's do number 7, because it's similar. Sine of 5x. Okay, so we have to integrate sine. Integrating sine would move up to what? Cosine. And when you take the derivative of cosine, you get negative sine. So it has to be negative cosine of 5x. So again, that stuffing and chain rule stays the same. And then divide by the derivative of 5x, which is 1/5. Plus c. Since we're doing a, oh gosh, I can't ever remember those words. Indefinite integral, it's plus c. And you can always check. Derivative of cosine would be sine of 5x times 5. Well, be if you did now the derivative of negative 5 cosine of 5x plus c, the derivative of cosine becomes positive sine of 5x negative, right? You have a negative cosine. Nope, so because it's negative cosine, it will become positive sine. 1/5, but we have to times by 5, so the 5's cancel out and we get the original. Okay, I'll help you with number 8, and then I'll let you try the others. Secant of 2t, tangent of 2t. This is, look at their parts. Their parts are the same, right? That is important. Otherwise, we have to use it like a u substitution, probably. Secant 2t, tangent of 2t. When we take the derivative, do we get secant tangent? What function, when we take the derivative, do we get? Yeah, because when you take the derivative of secant, you get secant tangent. So when we integrate secant tangent, we're going to get secant. And since the parts match, it's secant of 2t Again, divided by 1 over 2. Well, divided by 2, which is just 1/2, plus c. Okay, so with your group, some of these might need some group effort on. Try 9, 10, and 11. See how far you can get. Actually, well, I guess we only have 9 as the numeral, huh? Well, number 10 is just saying dy dx is this, so you're going to be integrating, well, I'll do number 10 in a minute. Just do number 9. Work together with your group. Talk it out. Okay, if I took the derivative, what would give me the derivative equaling cosecant cotangent?
One of them, the secant or cosec one or negative anyway. So the change to 3
When you think you have it, raise your hand. Look at what you have. Good. Okay, now I saw a lot of you look this up in your chart. This is kind of one I think you should know. It goes with the, what's the reverse of that? Instead of secant, secant, tangent, it's cosecant, negative cosecant, and cotangent. So if we want the derivative to be cosecant cotangent, and there's even a negative, the integral is cosecant. So
I gotta check to make sure that it was negative, because that's part of the sequence.
Yeah. So that one's negative, the other one's a positive. So we get cosecant. Notice their parts have to be the same. And in this case, their parts are both x. Then we divide by the derivative of x, which is 1. That doesn't do anything, so you can just put plus c. Oh, yeah. Yep, you're right. Positive 3. Yeah, because the derivative of negative cosecant cotangent is positive cosecant. Yep. Okay, so number 10. dy dx equals 3x squared minus cosecant squared x. Now, when we take the integral, you can see on all of these, when you integrate, the dx is always with the function. Okay? Well, dx is over here with dy. So we need to times it over, make sure you're doing everything, and then we can integrate both sides. We can integrate dy, and we can integrate 3x squared minus cosecant squared x. Make sure that's all in a group, in parentheses or brackets, dx. Because remember, dx is your width. Okay, what's the integral of dy? The antiderivative of dy? Just y. y equals, I'm going to let you do the antiderivative on the right side.
Why does the dx?
We just moved it over. It's still there. We need that in order to integrate. Okay, so I'll let you try the right side and then do the same on number 11. And do number 11 too. You might want to talk about number 11 with each other. Good job on that one. This one you made one little error. There's some weird stuff going on there. Just integrate 3x squared. Where'd you get the 9 from? In a minute.
Oh, duh. Oh my gosh. We don't even need to do that. Over something. Oh my god. Oh, that's annoying. Oh no. This. You lied by this. There we go. This is 4TQ. So this is like this. Oh, I see. Is the chain rule of this. You know what I'm saying? Yeah, exactly. Like we just end up with it. It looks like we're not doing anything. So, yeah, tangent. This is tangent to this one. What was that trying to do?
Yeah, number 11 is easier than you think.
I know, it really is.
Okay, who wants to come show the rest of number 10? Someone who hasn't been up. Okay, thanks, Jake. I can move this up too if you don't have to be so low. What's the... Look at our over here. We need the derivative to be negative cosecant squared.
The derivative of cosecant is negative cosecant cotangent.
But cosecant squared is the derivative of... Negative cosecant squared is the derivative of cotangent. So cotangent's derivative is negative cosecant squared. See how there's two of them? So I don't know what were you thinking here? Are you trying to, did you do like cosecant x, and then like...
I see what I did. I did the chain rule on that. So it was cosecant x to the power 2.
Oh,
Yeah.
okay.
So that's what
Okay, and actually it wouldn't really be chain rule anyway, it'd be product rule, because it's not cosecant of I keep doing cosine, cosecant x. Okay, so you get why it's just cotangent? Whoa. Okay, so I'm just going to change this here, plus C2. Yeah, we need to get rid of the 2 as well. And it's negative cosecant squared, so it'll become positive cotangent of x plus c. Okay, now number 11. I saw Rebecca had it first. She was the first one I saw had it correct. Can you come up and show what you did and explain why it works like that? Yep. Trained you well.
It
hmm
should be exciting to have under that.
Yeah, you know, in the night classes I was just teaching, they have the old smartboard I used to have, and it's always on skinny marker. And just like this new smartboard, it's just, I haven't been able to figure it out.
Have you ever had something come in and change yours?
Well, something in the notebook program, because it's really annoying. Okay, can you explain how you got that so easily instead of having to undo the product rule?
I just saw that it was chain rule.
And you knew it was chain rule because what?
It's like inside, like this is the derivative of that.
Mm-hmm.
So
The derivative of t to the fourth is 4t cubed. So she made the connection that that multiplier up front was the derivative.
So I knew that it would just be part of this.
Mm-hmm. And you end up dividing by 4t cubed, right? Which is why the 4t cubed goes away.
Mm-hmm.
Okay, great. Thanks, Rebecca. Okay, now I think the next one we actually find that value of c. Solve the initial value problem. Okay, initial value means at an actual point. You can see here we have y of -1 equals 0. So we need to get dx over, again, we times by dx to everything. Make sure you put that in a group. Okay, and then we'll integrate dy, and we'll integrate 9x squared minus 4x plus 5. Make sure that's in parentheses, dx. After we've integrated it, then we're going to use y of -1 equals 0 to find initial, this is the initial value, and we're going to plug that in to find c. Okay, so Alex, what's the integral of the antiderivative of dy? Y, great. And when we integrate that trinomial, what would we get, Alex? Plus c. Good. Is everyone comfortable with that? That's just a polynomial. Okay, now we have initial value, so we're going to plug in the initial value to find c. So we're going to plug in a point. What is the point we're plugging in? Yeah, the x is -1, the y is 0. Okay, so where y is, we put c, or 0. Where the x is, all of those x's, we're going to put a -1. Make sure you use parentheses. That's very important because we need to be cubing and squaring the sign. And see, now everything's a number except for c, so we can actually find the value of c. Right? What is 3 times... No, y is -1, see in the point? Or, sorry, x is -1, y is 0. Okay, 3 times -1 cubed, well, this ruler, stay. -1 cubed is -1, oh, hallelujah. 10th graders, they're like, +1? No, they don't know. We've been doing -x cubed all week. So I'm glad you guys know this. And so make -3, right? -2 times -1 squared. -1 times -1, +1 times -2 is -2, minus 5 plus c. Okay, find the value of c. Misha, you already have it? What'd you get? 10. Because here we have negative 10 plus c, add the 10 over, c equals 10. Okay, so our equation now is y equals 3x cubed minus 2x squared plus 5x plus 10.
Question. How do we get the points from the
The initial value?
Yeah.
Well, this is given, and this is saying y evaluated negative 1. When you're evaluating at the x. And it says y equals 0. Y equals 0. So y is 0,
So it's like
and the x,
F
yeah.
instead of F is Y.
Yeah, it's like f of negative 1 equals 0. So your x is negative 1, your y is 0. Okay? With your table, do number 2. It's another initial value problem. So you have to integrate, find the value of c using the initial value, and plug it back in. Talk about it together. Increase the power, divide by the power.
Negative x, negative y.
What are these problems? Not problems. What are these equations?
Okay, this one is looking good. I think we've all gotten the same C value. So I'll just show the work really quick. Increase by 1, divide by that power. Is that what you guys got? Or y equals, some of you put it down back on the bottom. Okay, what is the point you're plugging in? 2, 1. So wherever there is a y, you put a 1. Wherever there's an x, you put a 2. Exponents first. So 4 over 2. Then we do division. No, actually, let's just combine them. I think that would be easier. 3/2 plus c, subtract 3/2, which is the same as subtracting 1.5, right? So we have negative 0.5, or most of you left it in the fraction. So the answer, though, is the equation. Y equals negative 1 over x plus x squared over 2 minus 1/2.
So, what would be an example of how they would ask this on like a assignment or test? Because I guess just solve the initial value problem. Like how would make it so problem?
Well, let's see. In 7.1, if it says at the beginning of 7.1, it says find the general solution to the exact differential equation. That's just finding plus c. And then it says solve the initial value problem explicitly. And they will give you a point. If they give you a point, that's an initial value problem. Okay, explicitly means find the exact value of c and plug it in. Okay, there are 2 more, I think. There's number 3, and then we'll do that. Oh, do you guys not have the number 4? Okay, well, number 4 has a trig function, so we'll do that one together. But do number 3 with your group. Again, it's initial value problem. Ooh. This is fun. Look at that. Okay, try it with your group. Talk through it. You guys have made, I really liked the tangent problem you all did together, how lots of you were trying to undo part rule, and then all of a sudden you had this epiphany together that it was easier than you thought it was. So. Talk about it. Talk, talk, talk. This one slightly has an extra layer of difficulty.
Plug it in. Okay, so now I have to do this process. Do you want to do
Yeah, that's what I was trying to do, but I don't know how to do it. I didn't even do it.
Y equals 1, 0 here. I think this, because that was here. The y equals 0, so it's just the same here. But I think they just gave us, I don't know why they gave us a time. Oh, because the first one is plus c. There we go. Okay. Can't move on. Until the first one, all of it. Also, we have to add another constant word. Plus
You done?
y.
How can you solve a plus c?
You have to add the constant. Oh, I don't, sorry. I don't need it. I think I need to add r. Yeah, just because y prime is better 2y.
Good job. You got it. Is this your first one?
Yeah.
Mhm.
Ready?
Mhm. Yep.
Yeah, yeah, okay.
What's going on? So this is y prime. Yeah. So you plug in y prime on that.
Mhm. That's why they give you two initial values.
It's nice when x equals 0.
Yep. True. Okay, Gisu, do you want to go put your first steps down? Just right below the work. Great. What do you guys think? Great. I'm just going to squeeze in at the beginning the first step that you did kind of in your head. At the beginning, you still need to times by dx squared, right? Dx squared. And then you're going to be taking the integral of d2y equals the integral of 2 minus 6x dx squared, which is what you get there. Okay? Also, we have to, I heard great conversations about you have to do it twice, and you have to each step plug in your c to get the new equation, and then do it again, plugging in the next layer of c. Okay, so who hasn't come up yet that can come show us the next layer? Reed, have you been up? Make sure you put all that in parentheses because everything's being transferred to x, but good. Okay, is that what everyone got for your, before you use the initial value? Great. Yeah, 0 is way nice, right? C equals 1, sweet, and then just plug it into your function. And box it up. Cool. Any questions on that? Thank you, Reed. Thanks, Gisu. Any questions? Okay. At the bottom, or maybe on the side, wherever you have room, this one's not long. One more. Number 4. Solve the initial value theorem using the fundamental theorem of calculus. Hint. Your answer will contain a definite integral. Okay. Here it is. dy dx equals the fourth root of tangent x, and y equals 6 when x equals 3. Okay, last one. Work it out with your group. Maybe you should also talk about what the fundamental theorem of calculus is. Remember, there are two parts to the fundamental theorem of calculus. We learn part 2 first, and then A few lessons ago, we learned part 1. And we'll look at your 6.5 notes. And look at the very last part of your notes of 6.5 trapezoidal roll. Okay, here's the bottom of our notes. That's the first part of the fundamental theorem of calculus. You remember this on your notes? Okay, so we did the derivative of an integral from 4 to sine x of a function e to the t. Notice we have a t instead of an x, plus 2 dt. What was the trick? Derivative of the top, derivative of sine x is cosine x. So e to the sine of x plus 2. Okay, so the x's are replaced into all the t's. So back to our notes. Now remember, your answer is going to have the definite integral. Okay, so we still need to do the same thing we did on the other problems here. Get dy alone. So we have dy equals the 4th root of tangent x dx. Okay, then we integrate. Well, I'll just put it right here so I don't have to rewrite it all. The integral of dy is y equals the integral from 4 root tangent x dx. And the fundamental theorem, let's see if we go back to this, has from a to some g of x. Well, our a is what they give us, from 3 to some x. Okay? But that reverses all the x's need to go back to t's. dt. Because the one on our notes, we're taking the derivative of the integral. This is just the integral.
So where does the dt come from? I know in the notes. I saw it in the notes.
Because this was, we're taking the derivative of the integral. Now, on our notes today, we're just doing the integral. So it's a function with respect to t.
Where does it tell us the function with respect to t?
Because of the fundamental theorem of calculus. The function is with respect to t in the fundamental theorem of calculus. And you integrate from a to something with an x. And it says in the directions, use the fundamental theorem of calculus. Okay? And, so, I don't like that, the way that looks. X dx. So this becomes 3 to the x, the integral of 4th root tangent of t dt. Now, any ideas what you do with the 6? It actually just goes on the end, because when you go back up the scale, you take the derivative of y, you get dy dx. When you take the derivative of 6, it just goes away. And when you take the derivative of this, using the fundamental theorem of calculus, you get the original back. Okay, all the t's become x's. Okay. I don't know if there's even many on your homework like that. Do you have your homework sheet? It does say a couple of 7.2. You can actually do those 7.2 problems. So I want you tonight to do the whole first box, the 5 in 7.2 and the 7.1.
So just this first one.
Yep, just the first box. It's just antiderivatives. And the next time we'll keep going with 7.2, which is on u substitution.
So we'll have questions on this next time.
Yep. Okay, so we have like 10 minutes you can work on in here. The trapezoidal rule 6.5.